Good afternoon. Welcome back from the lunch break. Yeah, I will give you first a short introduction about our company, W2 Environment. So my company is based in Northampton, and we're an engineering office specialized on Tannery effluent treatment. We do some consulting, some research, and also we offer some training specifically for the dairy industry. And I would like to present you our project in France. Actually, we carried on this project last year in the Tannery TCIN. Tannery is near the Madagascar in Indochine, which is situated next to Tours, or the Loire Valley to the north of France. And we use the technology which is a combination of Reedbeds and nanofiltration for polishing of the effluents. So actually it's a combination of the low-cost technology, which is working very successfully now in many cases, and nanofiltration afterwards to polish the effluent and to discharge to river. So what is the concept of this combination of technologies, and what are the objectives? Why we choose this technology? Actually, Reedbeds offer a low-cost biological treatment. They're normally applied after a primary treatment plant, and they provide for a good effluent quality, which afterwards, in combination with membrane technology, can be recycled. So in this case, the company can save fresh water and can also save discharge volumes or operation costs of the effluent treatment. So the water has a very good quality, it can be directly reused in the tannery. And also further advantage is that this combination of technology, the effluent quality meets all chargeable parameters. So actually it's allowed to discharge the effluent. It has even a better quality than required. And the plants are very compact, membrane plants. So actually, if the production increases in the tannery and there's more wastewater to be treated, some more modules for the nanofiltration can be acted on. So here we have the initial treatment, the Reedbeds. You can see here practically the effluent after primary treatment is discharged practically to the Reedbed plant. The reeds, Fragmentis australis, or in the front you can see iris, are transporting oxygen to the root zone. Bacteria develop there, and they degrade the organic pollution in the effluent. So further advantages of Reedbeds that the operation costs are very low. Nature does practically the job. And that no surplus sludge is produced. As we all know, surplus sludge or sludge landfilling is very, very expensive. And they don't smell, because no air is stripped actively through the matrix. The Reedbed performance is very reliable and good, but in wintertime, Reedbeds perform a little bit less well than in the summertime. And for that reason, the task was to polish the effluents with the nanofiltration membranes to achieve also the discharge limits in wintertime. And here you can see the first nanofiltration plant after Reedbed treatment, which is used for tanneries. And the nanofiltration practically provides for a very good quality, which is very stable. There's of course a concentrate being formed, which is about 20% of the overall effluent, which goes through the membranes. And this concentrate is being sent back to the primary treatment plant, undergoes again a primary treatment with coagulation, flocculation, and then following afterwards the Reedbed treatment. And the effluent is then discharged and meets the very strict discharge limit of less than 125 milligrams per liter of CO2. A further advantage of nanofiltration is also that salts are partly retained. Sodium chlorides are very small particles, they go through the membranes, so we don't notice any concentration effects. Sulfates, equivalent ions like sulfates, like chrome, are retained in the membrane, go back to the primary treatment, and then are removed during the primary treatment. So we didn't notice any concentration effects. And further advantages, what is more known maybe are reverse osmosis membranes, but reverse osmosis has to be operated at a very high pressure, which makes it more expensive in the operation costs in terms of energy. Reverse osmosis plants normally operate between 20 and 25 bars, and here we're talking about about 10, 12 bars of pressure which I applied. So therefore, a nanofiltration is much more economically feasible for the task polishing final effluents before discharge. Here we have the result. Actually, this is the permeate, which is collected in this permeate holding tank, which has an overflow and which is afterwards discharged. A part stream goes directly from the reedbeds to the discharge point, and you can see that on the next photo. And actually we use the permeate, which has a COD of 30, to reduce the COD after the reedbeds to achieve exactly the limit of 125 milligrams per liter of COD at the discharge point. And all the surplus can be used for recycling in the tannery. The water has a very good quality. It's actually also drinkable. It is slightly salted, but it has no viruses and no bacteria, and no big organic molecules, and is therefore a very good effluent for recycling them. We are now there at the second stage where we test the recycling of the permeate, and to see how this permeate, which fraction and how much can be used and be mixed with the incoming groundwater, and to provide for a consistent high quality leather. The tannery is producing exotic leather for the Hermes group, is part of the Hermes group, and they produce mainly lizards, alligator, and crocodile. Actually, it's a high quality product for the high price market. So here I would like to show you some results. You can see on the left side the feed concentration. That's the feed concentration after primary treatment, which is well operated. I gave you a range between 800 and 1,300 milligrams per liter per COD. And as you can see, without any operational costs with the Reedbed, COD can be reduced down to 342, and not many conventional plants achieve that. In the winter time, in the summertime, the average results were much better. And after Reedbed, after the nanofiltration treatment, we achieved a reduction again of 90%. So a concentration of about 36 milligrams per liter. And you can also see the continuity here, measured in Siemens, between 6.5 and 7.6 in the feed. And after Reedbed and nanofiltration treatment, we are 0.8 to 1 millisiemens, which is almost salt-free. That is less than half a gram of sodium chloride. And seawater concentration is 30 grams per liter. So we also achieve here a reduction of 87–88%. The plant is designed for a capacity of 165 cubic meter per day. Actually, by reusing the permeate, the plant allows the tannery to increase the production because they can reuse water. And as many companies, many tanneries allow only to discharge a certain volume, and, which limits the capacity. This is a big advantage, of course, for the tannery. The Reedbeds were installed about 5 years ago, and 7 beds in series. The tannery design took lots of pilot trials of home to test if the Reedbed technology is suitable for the tannery effluent. They achieved very good results, and they have about 150 square meters of The surface area of the reedbeds look very nice, and actually like a part, not like the effluent treatment plant. And here you have some more details for the nanofiltration plant, which has 14 spirals and ring modules in series, and a permeable capacity of 6 to 7 cubic meters per hour. Here we still have the concentrate, which we have to send back. These are 2 cubic meters per hour, and we achieve a recovery rate of about 77%. The most important thing are the costs too, and you can see here that the installation costs of the Reedbed plant was not very expensive. What the company has to install is practically a plastic liner, and has to fill the whole up, the Reedbed up with gravel. Normally river gravel is used for this purpose because it's the best matrix for reedbeds. And the nanofiltration plant, all constructed, connected with mechanical and electrical installation, was about 160,000 euros, so we have here a total turnkey cost of 200,000 euros. And also presented here the operation costs in terms of energy, with the nanofiltration plant, 1.75 kilowatt per cubic meter, that's less than for a single reverse osmosis plant. And that's the price per kilowatt in France. The manpower, the plant is not work intensive, the plant is completely operated automatically, but certain intervals in the rings have to be cleaned, and so we took about 1 hour of manpower. We calculated that based on our experience over the last year. As a pre-treatment, filter cartridges are used to guarantee that no suspended solids enter the membranes, and these filter cartridges have to be changed normally once a month. We add some anti-scavent to reduce the osmotic pressure, and here we have also the cleaning. There's one time every 3 weeks over the whole year. The sanitary costs, maintenance is normally calculated for about 2.5% of the capital or investment costs. And so the total operation of the Reedbed nanofiltration plant gives about 0.54 euro cent per cubic meter, sorry, over the data collected over the experience over the last year. So, to conclude, I would like to say that this combination of Reedbed and membrane technology actually seems to be a very good solution for tanneries. The investment costs are low, the operation costs are low, there's not much maintenance required, and it's can be actually operated to achieve exactly the limits, and all the surplus can be reused for recycling purposes in the tannery. And here you can see the discharge point where we practically mix the permeate from the reverse osmosis with a small part of the effluent from the reedbeds. Like that we can avoid concentration effects, and at the same time work exactly towards the limit of 125 milligrams per CO2. So thank you very much for your attention, and looking for questions.